Good day, viewers. Today, a lot of year 2 students have been disturbing that I should do videos on Bernoulli equation. So throughout this week, I'll be dealing with Bernoulli equation and how to solve a lot of problems, especially for year 2 students. Do it to share the link of this video to a lot of people in year 2, and also subscribe to my YouTube channel because I'll be deliberating on Bernoulli equation, which is elementary differential equation. And everywhere you see Bernoulli equation, it is always written in this format. In any way you see Bernoulli equation, it is always written in this format now. So when we see a question like this in this format, you will know that I will solve a lot of examples so that you will know how to, when a equation is Bernoulli equation. So now, if we have something like this, it's for you to divide everywhere with this. So now, if I divide everywhere with this with y exponential n, that is I will have something like this: y divided by yn is equal to this divided by this. So remember that here now becomes 1, and according to the law of indices, this is also equal to this plus px. According to the law of indices, when the bases are the same, this is also equal to this 1 minus n is equal to this. Now here becomes 1. Now after the first step, when you divide this with the power of n, the power with y raised to power anything, when you divide that, I'll show you in our next video how to choose from x and y to divide. I will show you everything. Now when we are done with that, the second step is to bring down the power. Now the power of this one, not this, is only this, the power of this. Can bring, you will say that z is equal to y1 minus n. The only one that you always take it to equal to z is only this one that is here. Only this one. We are trying to make this the subject formula. Only this. Now let's differentiate this now. Dz now with respect to x. We are going to differentiate dz now with respect to x. There's no x now. That means that will be implicit function. What we will do is for us to bring down the power 1 minus n, then y 1 minus n minus 1, because you always minus 1 from the power. Then you add the y, the x, because it is an implicit. Now, so dz dx now is equal to 1 minus n. 1 minus 1 now is 0. So what is remaining there is only this, dy dx. If you can check now from the equation now, we are going to make this one equal to this, y raised to power minus n dy dx. So what will I do to have this equation that is here now? This is what I will do. Check this now. What I will do is divide both sides by 1 minus n. That is, if I divide both sides by 1 over n, that will be 1 minus this dz dx is equal to y this dy dx. What am I doing like that? So that I'll be able to have this as this. Remember that when you take this to be your z, after you have differentiated, the next thing is for you to solve your mathematics, so that when you solve your mathematics, so that this will appear in the derivative. Now you make this the subject formula. Now y raised to power minus n dy dx, look at it here now. Have you seen? Look at it here now. So that means that everything here now is equal to this. I will bounce back to my equation that here, I want to write this equation. That will be 1 all over 1 minus n dz dx, because this is equal to this now, plus p all over x. Y, I take this to be my z, that is z is equal to q all over x. I'm going to do a lot of solving on this. All what I want you to know now, the major thing is this. When you know this, that means that what I'm going to do this week, you really understand Bernoulli equation is the topic of the videos for this week. Remember, you divide with the powers. After you divide with the powers, you take this